All right, so this is our Unit 2 practice test review. So if you don't already have one of these printed out and completed, you are a little bit behind, so please go back and try this first before you watch this video. All right, so let's go ahead. This first group is just we're going to generate an equivalent algebraic expression where only one of the variables, that's x, y, or z, there's only y and z here, appears once. Okay, so let's go ahead and zoom in and look at each one of these one at a time. Okay, so we have two quantities multiplied by each other. This is still just one term, and let's go ahead and identify our constants with blue, our y's with red, and our z's with purple, and do one at a time. Okay, first things first, look inside the parentheses and see if there's any like terms to deal with, and there are not. Okay, so now we're going to move over to this term and clear this exponent. All right, in order to do that, we have to distribute the exponent to each term. All right, so our first line is going to be over here. Just carry down this -2 y cubed and z. We can clear the parentheses. It's not a big deal to clear the parentheses there. Okay, now we're going to clear the parentheses for this set of terms by distributing the squared to each one of the terms inside of here, including the constant terms. So 6 squared is 36. Y to the 10th, so this is a exponent raised to an exponent, so we multiply the exponents together. So that's y to the 20th. Okay, same thing with the z's. Multiply the exponents together. This is going to be z to the 16th. Okay, so now we have our row of like terms together. So now we have to multiply our like terms together. So we have a -2 times a -36. So that's going to be a -72. Okay, now when we're multiplying our y's together, since you're multiplying the same bases together, you add exponents. So this is y to the 23rd, and then you add, this is an invisible 1, remember that, it's an invisible 1 when the exponent's not shown, right? So this is z times z to the 16th, so you add the exponents, this is z to the 17th, and that's a z, whoops, z to the 17th, and there is our answer for that one. Okay, moving on to the next one. Again, we're going to just go ahead and I'm going to keep blue for my constants. Okay, there's just a 1 in front of this negative sign, or sorry, behind that negative sign. Okay, so because it's just invisible, we're going to leave that as a -1. Okay, and my x's I'll make pink. Yeah, I'll make my x's pink, which look like red, but they're a little bit brighter. My x's are pink. My y's will be red again. Y's are red. And then I have a z, a purple z, and then another purple z. But this one is z to the 0th. I'm just going to ignore that because that's a 1. So that goes to 1, so when I transcribe this next line, I'm just going to negate that 1 because this is a 1 and anything times 1 is itself. Alright, so this is what I'm doing when I'm clearing things out of the parentheses. So I consolidate any like terms, nothing like terms, that 1 can go away because that's just 1, and then there we go. Okay, so right away I'm just looking at my negatives and my negatives here. Okay, well, this negative and that negative are going to cancel each other out, right? So I'm going to have positives there. So I can go ahead and do clear these parentheses. 4 times 2 is going to be 8. I've already done my constants there, right? So let's go ahead and clear my constants in that first thing. And now I'm just going to go ahead and write x to the 10th, x to the negative 2. All right, that's a good way to line it up. Okay, and then I'll go to my y. I have y to the negative 4th, and then y to the 3rd. Okay, I'll mark these off while I go, just to make sure I don't forget any term. And then I have z to the negative 2, z to the negative 2. Got that one, and I already combined these ones. My negative 2 times 1 was 2, right? And then I did 2 times 4, which was 8. So, right, so now I got all that stuff done. There were no exponents, so this just kind of carries everything down. Now I got everything in a line, so I just multiply everything together. This 8 carries down to my next line. Right, so remember this has a negative, this has an invisible 1 in front of it, or as an exponent, excuse me. So I add exponents together. I add the exponents together when I'm multiplying the similar terms. So this is going to be 1 x to the 1st times x to the 10th times x to the negative 2. So I just subtract the 2 there. Right, so that's going to be 8. Right, 10 minus 2 is 8, plus 1 is going to be x to the 9th. Now look at my y's. All right, it's going to be y. So let me just go ahead and, okay, I got all those done. Okay, negative y plus negative 4y. All right, so negative 4 plus 3 is going to be y minus 1. And then I still have this z to the negative 2. This is an acceptable answer. Okay, you can also write this as 8. And then we have x over 9, x to the 9th, excuse me, x to the 9th. And what do I do if I have, this is or, if I have a negative exponent? How do I make that exponent positive? Well, this thing goes over here. You send it to the bottom. Okay, you could write that as a 1, or you could just leave it as y. Okay, and then this would be z squared. Okay, so this could be, this is an invisible 1. Okay, so you can write it as an invisible 1 if you like. Right, so either one of these answers is acceptable. All right, moving on to the next one. Okay, first step, what I like to do is to kind of color code everything. If it helps you, I do it to show, to make it obvious what I'm doing here. Okay, I have an a squared. I'm making my a's red. Okay, and I'll make my b's blue. Nope, I'll use blue. I'll make my b's purple. Okay, my b's are now purple. Okay, but I have one of these monomials is squared. So let me do that first. Now this is tricky. Okay, this is tricky. I have a negative value, and I'm squaring it. Okay, the negative sign is inside the parentheses, so you have to square the negative. So when I square a negative, it becomes a positive. Okay, so I'm going to go ahead. Nothing happens to this one. This is already simplified, so I'm going to carry down everything and clear the parentheses. A is to the first, and then B to the third. Okay, now I'm going to do the math of this one and clear the parentheses. Negative 4. This is the same thing as writing negative 4 squared, right? So negative 4 squared is 16. Okay, not the same as writing that. Okay, or this. Okay, either one of these is 4. Because of PEMDAS, order of operations, you have to square the first square the 4 first and then make it negative. So that would be negative 16, right? But since this is inside the parentheses, you square the negative sign, okay? So I just want to make that clear. Okay, and then you have to multiply the exponents. So 2 times 2 is a to the 4th, and then b to the 6th, correction, b to the 8th, b to the 8th. Okay, and then just like before, 16 times 5 is 80, and then add the exponents, a to the 5th, and then b to the 11th, b to the 11th, because 8 plus 3 is 11, and that is the answer for that one. That's 111th, b to the 11th. All right, so that's the first 3. Pause this and go to the next page. Okay, so this one looks like it could be confusing, but it's not really that confusing. Okay, so let's go ahead and dissect everything we got going on here. Okay, so we have our constants. Okay, we have this constant, we have this constant, we have this constant. Okay, let me zoom in a little. I guess can see that. Okay, it just looks really small. All right, then we have, we'll make C's red, and that's it. We only have two things we're dealing with: the C's, and then we have some of them are squared. Okay, so let's do the numerator and the denominator separately, and then we'll deal with the results after. Okay, so just work the numerator like it's its own question, and then the denominator like its own question, and then deal with what's left after it's all done. Okay, so the numerator, okay, you have this term right here, and you have to distribute the 4 into this. Well, you could also, this is actually an easier way. So this, no, let's just do this. All right, so you can distribute the 4 into 9. Hold on, let me get a calculator. So it turns out I have not memorized what 9 to the 4th is. All right, so 9 to the 4th, 9, let's see, you can see that 9 to the 4th is 65, 61. 65, 61, so that's going to be 65, 61, and then C cubed to the 4th, is going to multiply the exponents together, is going to be C to the 12th. Okay, and then there's no exponents for this one, so we're just going to make that negative 2C squared. So that's the numerator, and then the denominator is going to be, well, 3 cubed is 27, and then C to the 5th times cubed is, multiply the exponents, is C to the 15th. So that is our first line of mathematics there. Okay, our second line is just going to be doing the numerator. Okay, simplifying the numerator a little bit. So 6561 times negative 2. I should show you that better. So let's see. Maybe if I turn this off. Oh, that made it worse. Maybe if I turn this off. That made it worse too. Okay. So there we go. So 6561 times negative 2 equals 13,122. Okay. So that's going to go. That's going to be negative 13,122, and then our exponents are going to add because they're multiplying the bases. Right, so it's going to be C to the 15th. Well, that turns out pretty nicely. And then it's going to be 27, still on the bottom, 27 on the bottom, and it's still C to the 15th. C to the 15th on the bottom. C to the 15th. 12th. Oh, this is 14th. Not this is the 14th. 14th. Okay, almost made an error there. Okay, this whole thing, because this is negative, we can just make this whole thing negative. This whole thing is going to be negative. Okay, that's a C. 20. I almost forgot the. Man, that was a really weird transcription error. 27 C to the 15th. Okay, that was my brain got a little scrambled there. Check my work. Okay, so now this is kind of easy. We look at let's look at our constants. So we do that 13,122 divided by 27. So 1322 divided by 27. Divide that by 27, and it gets a nice round whole number. This is going to be equal to negative 486, and then we can this is the rule where the quotient rule where you subtract the numerator from the numerator less the denominator, so it's going to be 14 minus 15, or you set them to war, where you're just like, okay, well this one goes against that one, and this one wins, so this one's gone, and this one took all but one, right? So this is going to be over C. Well, that should be red. That should be red. So this would be red. So C. Okay, or if you were like, okay, you could also do it like this. Okay, so this is a correct answer here. But if you were like, okay, I'm going to bring this is negative 486. If I'm going to bring this one up here, right, and put the 15, it would be C to the 14th minus C to the 15th. You'd have C to the minus 1. Which would be that, and either one, that'd be negative, right? That either one is an acceptable answer. Okay, so there is that. Those two answers. This answer is good, and this answer is also good. Both of those answers are equivalent and acceptable. All right, so here we go. Let's zoom out on this one a little bit. Okay, so using the laws of exponents, let's write an equivalent expression that has something to the x. Okay, well, this is pretty easy. Okay, so you know that we have 7.3 has got to be our base, right? So 7.3 is our base. 7.3 is our base, and then we have a parentheses, right? And you know that if we use the two things that multiply each other together, well, we got 7.3 raised to the 4 times x equals 7.3 equals purple equals 7.3. Let's do this so it makes it a little bit more obvious. 7.3 4 to the x, right? Because that's the rule of quotients. So 4 to the x, 4x, right? So you have the x, you have the 4, all right? So that's asking you, hey, show you understand the law of exponents. Okay, so that's what it's asking there. Okay, and here it's saying, hey, show the law of exponents. Use the law of exponents to show you understand how to rewrite this using the quotient rule. It's just undo this using the law. So show the law of quotient rules in reverse. Okay, so you have which one goes. So 5 is the base. 5 is the base. 5 is the base, right? And then you have 3x minus 7. Okay, so 3x minus 7. So your 3x. So both of these have to be multiplied by x, right? So 3x minus 7x is going to go like that, right? So because it's going to be the top times the bottom, right? And I think that this, oh yeah, here we go. All right, so it's going to be, so what you have here, 3x minus 7. Okay, so after you do this one, you multiply everything out and you say, okay, well this is going to be, okay, it's going to be 5, well I should probably color code this better, because you have to have the same base, okay, enabled in order to actually like use this, right, in order to be able to use the exponents, right, so 5 is your base, equals 5, and then you're multiplying the 2 together, so this is going to be 3, and I'll make this 3x, make this purple, 3x, and then it's going to be minus 7, we'll make this pink, minus 7, right, because it's going to be minus 7 up there. Okay, so that's how you figure that one out. Okay, you have to look at this is two functions going on up here, something raised to another thing. That's your law of power raised to a power. And over here you have a, this is your quotient law. Okay, so there's actually two laws happening in here. All right, next page. All right, now we're doing the sums of stuff. Find the sum of stuff. Okay, remember, in order to add stuff together, they have to have two things, right? They have to have the same base, right? That's like the same terms at the base, same base terms, and they have to have the same exponents. Everything has to be the same. So this one here, they're gonna ask us to distribute this 3x to the 6th into the 2 and into the x, like that. All right, so let's do that. So allegedly we should get that as one of the terms. Okay, so the first term we're gonna get is gonna be, well, this is going to be 3x, and then an x to the 6th times x to the 1st would be x to the 7th. Okay? And then, that's our blue. And then our red is going to be, our red is end up going to be 2 times 3 is 6 plus x to the 6th plus x 6x to the 6th, right? So now we have two of these, right? So nothing happens to the 3x to the 7th, right? But we have two of these, a 6x squared, right? 6x to the 6th plus 6x to the 6th. They have the same variable, and they have the same exponent, right? The constants can be different, so this is going to be 12x to the 6th. Right, so there's that one. All right, so here is this one. This is finding the product. Okay, so this was a this is a polynomial times a polynomial. Okay, so you're gonna multiply the first times the whole polynomial. Then you're gonna multiply the second times both polynomials. Okay. Or you can do it using, I'll show you the other way in a second. Okay, so the first term, we're going to make blue, right? So k squared, k times k is k squared. Then we're going to go k times negative 12, because this is a negative 12. Right? It's going to be minus 12k. Right, now moving on to our 7. Our 7 is going to be plus, because this is plus 7, plus 7k, right? And then it's going to be minus 12k. All right, so then we're going to add like terms. So our k squared, k carries forward. So our combined like terms, right? And then it's going to be minus 12, so it's going to become more negative. So it's going to be minus 24k plus 7. right? So that's that one. Another way to do it is we're going to have our first polynomial on the top. Maybe spread that out a little. Plus 7. Our other polynomial on the side, k minus 12, those two terms. And then multiply everything together. This is going to be k squared. K to 7k. 7k. This is going to be negative 12k. Right, and then this is going to be I made a mistake. All right, this is going to be I forgot a term actually. All right, so this is going to be let's see, 7 times 12 is 84. And this is going to be negative 84. So I forgot a negative 84 right here. And there should be, yeah, I forgot that one. All right, so this is going to be plus 7. There should be no plus 7 here. Plus 7k. I made a mistake here. Let me erase this one. Start this one from the top. Thought I checked this one. Okay. All right, so let's do this one again. This is going to be k squared. Okay, and it's going to be, you're going to do minus 12k plus 7k minus 84. There we go. That's the right one. All right, so now it's going to be k squared, and it's going to be 12 minus, or negative 12 minus plus 7. Okay, it's going to be minus 5k, and then minus 84. That's the correct answer there. And then here we go. We do the same thing here. We got our k squared, and then we got our plus 7k minus 12k is going to be minus 5k minus 84. And that's our answers for that one there. All right. Pause this for 1 second.